For this graphs of functions section, we will be talking a little bit of the graphs, a little bit of intercepts, how to graph, and then we're going to end this section with evaluating functions. So to start off, when you guys want to graph something, the first thing you have to do is identify what graph we have. We have several functions that we call the parent functions, and in this section, we're only going to be talking about 6 different ones. So the first ones I want you to know, and again, make sure you have somewhere on your notes, is a linear function, right? So a linear function looks like this. It's always going to be a straight line either going up or down. The equation looks like y equals x. And then domain and range are just there on your notes for fun right now. We're really not going to worry about them in this particular section. When you have something that looks like a v, this is what we call an absolute values function. And the equation looks like this, right? You're going to have y equals, and then every time you see 2 vertical bars, that just stands for absolute value. All right, the next parent functions we're going to be talking about is the quadratic. Quadratic is anytime you have something square. So if you have a variable square, this is a quadratic function, and it looks like this. It could look like a u or a backwards u, and this is what we call parabola. Now, the opposite of a quadratic is a square root. So every time you see a square root in an equation, we call it the square root function, and it looks something like this if we were to graph it. So it kind of looks like half a parabola, but facing either the left or the right, but it's just half of it. So up and down is going to be a quadratic, up or down, right? Left or right, just half of it is a square root. The last ones we're going to be talking about here is what we call a cubic. A cubic is when you have an equation that has a cube, so anything to the 3rd power. The function kind of looks like an S per se, but like a backwards S. It looks like a little snake there. And then the opposite of a cubic is what we call a cube root. So if you notice, it has a cube root. And this one, if you notice, looks like a cubic, but like falling asleep, right? So taking a nap. So it's kind of from left to right. So again, you do not have to know the domain and range right now. I just wanted you to know what parent functions are, what kinds of parent functions we have, and what they look like. So here I'm giving you a function, right? And they're asking us to identify what kind of function it is. So we have 6 options. It could be either linear, absolute value. It could be a quadratic or a square root. It could be a cubic or a cube root. So if you notice, nowhere in this function do I see a square root, a cube, a cubic, or little vertical bars for absolute value. So this right away is just a linear equation or a linear function. So you see how easy it is to identify. So right now, like I said, we're not doing any graphs, any of that. I just want to make sure that you know how to identify just by looking at the equation what kind of parent function it comes from. So if you notice, it doesn't look exactly like y equals x, but we know it's linear because there's no other exponents in there. All right, let's go ahead and try this one. So again, this one right off the bat, you see that there's a root in here. Again, we don't care about the 2 or the 7. We know that there's a root. If there's no little number here, it's an imaginary 2. So this is a square root. All right, let's go try another one here. Here, again, right off the bat, you guys, you should see the vertical bars. So as soon as you see the vertical bars, you should know that this is an absolute value function. So again, we're not doing anything. We're just making sure that we know how to identify based on the equation that they give us. All right, so in this one, again, there's no vertical bars, there's no roots, but you see that there's an exponent of 3. So if you look at your notes, you should see that this is what we call a cubic. All right. Okay, so from all the parent functions, right now we're just going to be focusing on the linear functions. The linear functions are the ones that look like straight lines, right? Like I told you, they either go up or down. So I have to make sure that we know how to graph a linear function, and they're super easy to graph. So these are the 3 steps you're going to follow. First thing you're going to do is that you're going to substitute 2 random values into the x's to find 2 random points. When I say random, I mean like truly random. You guys can choose whatever numbers you want. Of course, to keep it simple, we're going to be choosing small numbers. But if you want to go all crazy and use huge 3-digit numbers, you are more than welcome to do so. So step 1, substitute 2 random values. Step 2, you're going to plot both points. From step 1, we're going to get 2 points. So now we're going to plot them. And then step 3, we're just going to connect them with a straight line. Okay, it's going to be super simple. So let's go ahead and try one problem. So if you notice, again, right but just by looking at it, you guys should know, oh, this is going to be a linear function. Again, because there's no exponents, there's no roots. So we know this is going to be a straight line. So we could graph it. So again, like I told you, step 1, you're going to choose 2 random values. My first value that I chose was 1. Like I told you, to keep it simple, use small numbers. So I chose 1. Now what you're going to do with that 1, you're going to substitute it into the x. So instead of 3x, I'm going to put 3 times 1, and then I'm going to simplify. So 3 times 1 is 3, and then minus 1, I get 2. And now remember, we always have to write it as an ordered pair. How did I get this ordered pair? The 1 comes from the random number I chose that I put into the x, and then the 2 is the answer that I got. So we already have 1 point. To find another point, I'm going to choose another random number. I chose 2. Again, you could use 3, you could use 5, you could use 127, you could use whatever number you want. But I just chose 2. And I do the same thing. I come to the equation. Instead of x, I'm going to put a 2. So 3 times 2 gives me 6 minus 1, I get 5. And of course, I have to write it down as an ordered pair. So this is my ordered pair. The number that I put goes first, which I chose to be 2. If you chose a different random number, that would be your first number. And then the 5 is the number that I got as an answer. Okay, so look at that. We're almost done. Now, in order to finish my graph, I'm just going to plot these 2 points. And then step 3, connect them with the line. So I did both of them here. So if you notice, here's my first point. I come to the 1 on the x and the 2 on the y. I make a little dot. And then for the 2, 5, I go to the 2 on the x, the 5 on the y, and that gives me another point, and then I just connect them with a straight line. Okay, so that is super simple. On your homework, they might ask you for the domain of this. And again, you guys should already know how to figure out the domain, but I'm just going to give it to you here. For domain, remember, it's just how far does the graph stretch to the left and to the right. And just for a word, and you want to pick a little note on your notes, anytime you have a linear function like this one, your domain is always going to be negative infinity to positive infinity. Okay, so don't even worry about it. But just remember, this is only for linear. So this is a linear, means my domain is going to be negative infinity to positive infinity. All right, let's go ahead and try one more here. Graph f of x equals negative 2x plus 5. Again, choose 2 random numbers. To keep it simple, I went ahead and did 1 again. So I put the 1 in the x. I get negative 2 times 1, which is negative 2. And then I add 5, I get 3. Again, if you're worried about this, don't worry. This is just fancy notation. All you have to remember is you put a number in the x and then you simplify. So that gives me 1 comma 3, again, because 1 is the number I chose and 3 is the answer I got. And then I choose another number. So I made it a little more interesting, right? I chose a bigger number. I chose 5. And again, if you want to keep it with 1 and 2, go for it. But I chose 5, so that means 5 is going to go into the x. So negative 2 times 5 plus 5. So negative 2 times 5 is negative 10. And then I add 5 and I get negative 5. And of course, now I have to write it as an ordered pair. The number that I chose, which in this one was 5, and the answer that I got. Now, once I have my 2 points, I simply graph them and connect them. So again, 1, 3 is right here. And then 5, negative 5 is right here. And then you just make a straight line, and that is your graph for this problem. Again, if they were to ask you what is the domain of this, we know it's a linear function. So automatically my domain is negative infinity to positive infinity. And why? Because again, it's going to keep on stretching all the way to the left and all the way to the right. It just keeps on going forever. All right. Let's go ahead and go into some graphs that you don't have to worry about following steps 1, 2, and 3. Anytime you guys see an equation that looks like this, where you have x equals a number, this automatically is going to be a vertical line. I don't want you guys to be choosing random numbers and inputting into the equation, because this is too simple. So anytime, again, you have an equation that has x equals a number, it's going to be automatically a vertical line through that number. Okay, so let me give you an example. Let's pretend you open up your homework and one of the problems is graph x equals 2. Again, you don't have to choose random points. You just have to remember, okay, teacher said that when we have x equals a number, it's going to be a vertical line. So actually the graph for this one is just that. You go to 2, because the x equals, you go to 2 on the x-axis, and then you just make a vertical line up and down. You choose 2 random points wherever you want, and you just draw a line. That's it. Okay, so again, remember, x equals a number. It's always going to be a vertical line. Now, the opposite of this is what if I don't have an x equals? What if I have a y equals? It's the same thing. It's going to be a straight line, but instead of vertical, it's going to be horizontal. So again, anytime you guys see y equals, it's going to be a horizontal line. Horizontal lines are like the horizon, right? From left to right. So for example, you open up your homework and one of the problems says graph y equals 2. So again, you go to the y-axis, which is this one. You go to 2. And then remember, y equals our horizontal line. So I just draw a straight horizontal line. Okay, so these two slides were meant to save you time. So from now on, when you guys see an x equals or a y equals, there's no need to panic. It's just going to be either horizontal or a vertical line. Just remember, y equals horizontal, x equals is going to be vertical. Okay, the next thing we're going to cover here in this section are intercepts, right? You guys have to know what intercepts are and how to identify them. So in a graph, x-intercepts are wherever the graph intersects the x-axis. So remember, this is your x-axis right here. So my intercept would be -2 because that's where the graph intersects the x-axis. And then your y-intercept is wherever your graph intersects the y-axis. The y-axis is this one right here that goes up and down. So my y-intercept here would be 0, 4. Okay, so if I lost you there, let me know. But if you notice, x-intercepts is this little number here, 0. It's always going to be a 0 there. And the y-intercept always starts with a 0, and then it's the number where it intersected the y-axis. Okay, let's see if this made sense. Go ahead and try a problem. So here they're giving us the graph of a linear equation. They're asking us what is the x-intercept and what is the y-intercept. So super simple. X-intercept is where it intersects the x-axis. If you notice, it's at 1. But of course, we have to write it down as an ordered pair. You cannot just put, it's 1. You have to put 1, 0. So remember, it's your x value and then your y value. What is the y-intercept? Y-intercept, same thing, but where does it intersect the y-axis? Right there at 0, 3. Okay, so hopefully that made sense right there. All right, next thing we have to know, right? So it looks like we've been covering a lot, and yes, we still have a few more things to talk about. When we have a graph, you guys already know how to find the intercepts, the y-intercept and the x-intercept. But we also want you to know how to identify if the graph is increasing, decreasing, or if it's constant. And this is how you're going to find out. So when we ask you for, hey, give us the interval where the graph or the function is increasing, all you have to look is to see where the graph is going up. So that makes sense, right? Increasing is where it goes up. Now, if we ask you for decreasing, all you're simply going to do is stare at the graph and tell us where is the graph going down. Now, the last one, which might be new to you, is where the graph is constant. Whenever the function is constant is where the graph is neither going up nor down. It's just staying constant. Again, I don't expect this to make sense just on the wording. So we're going to be working on 2 examples right now. So you can see what we mean. So just remember, increasing means up, decreasing means down, and constant is just constant, right? So it's neither going up nor going down. Okay, so let's go ahead and look at this graph, right? So this is a really weird looking graph. And we have to identify where it's increasing, where it's decreasing, and where it's constant. So the way I like to do this is like reading a book. You start from left to right, and you pretend like you're in a little roller coaster, right? So I'm going to pretend I'm in a little roller coaster. This is me right there. Woo, in a little car, right? And this is the start of the roller coaster. I'm going to go and then tell me what's happening, right? So if my roller coaster starts right now, what's happening to me? I'm going up. So right here, the graph is increasing from here all the way to here. So I'm going to draw a little line there. So there, from here to here, my graph is increasing. Now here, my roller coaster changes direction. Now I'm going down. So from here to here, I am decreasing. So I'm going to draw another little line there. So I'm putting my roller coaster into pieces, right? Here, what happens to my little roller coaster? It's steady, right? I'm not going up nor down. I'm just going steady all the way to here. So I'm going to make another line there. And then here, my roller coaster changes direction. I start going up. So since I start going up, I am increasing. So I'm going to cut it there. And then here I changed direction again, and now my roller coaster is steady. So here is the end of the changes. So if you notice, all I did is that I made a line every time my roller coaster changed direction. And like I told you, in the first part, I was increasing. In the second part, I was decreasing. In the third part, I stayed constant, I stayed steady. In the fourth part, which was really steep, I was increasing. And then the last part, I stayed constant. Okay, so I'm hoping that made sense. Again, you don't have to draw a little person, right? It's up to you. You don't even have to cut the graph into parts. I'm just showing you how I do it. And then that's it. You already identified all the different intervals. All you have to do is just write your answer mathematically. So when is it increasing? It was increasing here and it was increasing here, correct? Now, in order to write this in math terms, I'm going to go ahead and erase my little roller coaster. In order to write increasing in math terms, I have to write this interval here. And all you have to do is just look at the x values. What's all the way over here? Negative infinity all the way to -6. So that's going to be my first answer, right? Because this is increasing. Was it increasing in another interval? Yes, it was also increasing here, right? So that is from -1 all the way to, there's no number here, so this is 0. So those, my roller coaster or my graph was increasing 2 different times, from negative infinity to -6 and from -1 to 0. So that is how to properly write it down mathematically. I know there's a symbol in there that might be freaking you out. So let me just go ahead and explain it. When you have 2 different pieces as answers, so my roller coaster was increasing 2 different times, all you have to do is just put this little symbol in the middle. We call it, you don't have to know the name of it, right? But we call it the union. We use a little U just to let the reader know that we had 2 answers. You don't put a comma, you put a little U. Okay, so I'm hoping this is making sense. Now let's go ahead and do decreasing. Where was my roller coaster decreasing? It was decreasing here. And I believe that was it, right? Okay, so to write our answer, you just write from where to where. It was decreasing from -6 to -4. So that's why my answer for decreasing is -6 to -4. And again, I will count it wrong if you put -4 to -6. So just make sure you always put it in order, right? So it's the lowest and then the highest point. All right, the last part of my graph is the constant. Where did the graph stay constant? Okay, it was this piece right here from -4 to -1, right? It was just constant. If you notice, it was just there. And then also here, starting at, remember there's no number here, so this is starting at 0 all the way to, remember what keeps on going all the way over there? Positive infinity. So that's why my answer for constant is from -4 to -1, and then from 0 to infinity. Okay, one more thing I forgot to mention here. If you notice, all of my answers here have parentheses. When we're talking about increasing, decreasing, and constant, you don't have to worry about brackets. So if you want to make a little note on your packet, please go ahead and do that. For increasing, decreasing, and constant, we never use brackets. We just use parentheses for all of our answers. All right, let's go ahead and try one more problem just to make sure that we understand what we're doing. State where the graph is increasing, decreasing, and constant. Again, I'm just going to do it really quickly, just like I did. So I'm in a roller coaster here. I'm falling, 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 falling. Here, it changes direction. And then I'm increasing. I'm going up, 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 up. And then here, it changes direction again. Here, I'm keeping steady. And then here, it changes direction. I start falling up to this point. So in that point, it stops. And then here, I just keep steady. It doesn't change direction anymore. So I cut my graph into pieces. And then I'm just going to label what I said was happening. So from here to here, I was decreasing. From here to here, I was increasing. From here to here, I remained steady or constant. From here to here, I was falling down, so I was decreasing. And then from here to here, my little roller coaster was just steady or constant. So again, this is the way I do it. You don't have to do it like similar to what I'm doing. If it works for you, go for it. But this is how I cut my graph into pieces. Now let's go ahead and answer the question. Was it increasing? I was just increasing in this little piece. This is the only one that was going up. So that is from -8 to -6. So that's the only part of the graph where I'm increasing. Where was my graph decreasing? So it was decreasing from here to here. And again, don't think this is negative or -10. Remember, this one keeps on going forever. So it goes all the way to -infinity. And I know you're like, why is this you put -infinity if it's going up? Remember, we're talking about the x-axis. This one keeps on going forever that way. So -infinity all the way to -8. That's one of my answers. And it's also decreasing here from -3 to -2. So since we have two answers, you put one of them there, and then you put the little union in the middle. All right, let's go ahead and answer the last question for this problem. We have constant. We had two pieces of the roller coaster being constant. One of them was here from -6 to -3. So that's one of my answers. And of course, since this one was also constant, it was from -2 all the way to, remember, the x-axis keeps on going all the way to +infinity. Okay, again, I understand if this is confusing, just make sure you find a way that works for you. Again, thinking about it as a roller coaster helps me think about it. So that helps me. But if it helps you, go for it. If not, try to figure out something else. If you have no idea what I'm doing, let me know, and we could find a different way that might work for you. All right, the last part of this section is evaluating what we call piecewise functions. A piecewise function is something like this. You have f of x equals, and you have two pieces. You have two different functions that can happen. Again, we're not going to go into graphs here because these could get a little messy. We might talk about them later. But for right now, all I want to do is that you know how to evaluate. So again, a piecewise function looks like this. You're going to have a big brace here, and you're going to have different functions in here. You might have 2, 3, or 4 or more. Don't let it worry you. And then on this side, we have what we call conditions. And I'm going to show you what they mean in a little bit. So first thing I want to know is to show you how to evaluate a piecewise function. So in order to do that, we've been doing it all along. You're going to replace the variable, but now you have to make sure that you use a corresponding function because you have multiple functions. You're going to have to know which one to use. And then after you replace the variable, you're just going to simplify. Okay, so let me go ahead and walk you through an example, and then we're going to do a couple more, and that'll be it for this section. So look at this. We have a piecewise function because we have two pieces, and we have conditions. This is what the conditions mean. The way you read this is x is less than 0. Again, if you don't remember what this symbol means, remember it looks like an L, so it's less than. What this little thingy here is telling me is that this function, I'm going to use it whenever x is a number less than 0. If x is less than 0, I'm going to use the function on the top. Now, if x is greater than or equal to 0, I'm going to use the function on the bottom. That's pretty much what these little thingies here tell you. Again, I know they look scary, but don't let them freak you out. They're very helpful. So what's going to happen is that I'm going to give you something like this, and this means evaluate the function when f is -1. The first thing you're going to do is you're going to decide which function to use. You cannot just use whichever one. So you're going to look at this number and ask yourself, is -1 less than 0? Or is it greater than or equal to 0? So hopefully we all agree that -1 is less than 0. So all that means is that I'm going to come and use this equation. We don't care about the bottom one. Okay, so that's it. So now since you already know you're going to use the top one, all you're going to do is replace the x with the number that you have here. So I'm going to put 5 times -1. 5 times -1 is -5, and then I add the 2, so my final answer is just -3. So you see, that was super simple. It looks scary, but it's very easy to do. Okay, we're going to try 2 more, and we'll be done with this section. So let's go ahead and look at this one. So again, you have a piecewise function because you have two pieces, and I ask you to evaluate f of -2. Again, look at this number, 2, and see where it falls in the conditions. So is 2 less than 0, or is 2 greater than or equal to 0? So hopefully you agree with me that 2 is greater than or equal to 0. So it's not less than 0. So we're not going to use the top one. We're going to use this bottom one here. Okay, so all I'm going to do is I'm going to replace the 2 into the x. So I'm going to have 5 times 2, which gives me 10. And then I'm going to add the 4. So my final answer is 14. Super simple. Again, I forgot to do this one on the last one, but go ahead and put this one on your notes. In case I ask you for the answer as an ordered pair, remember it's the number that you input, which was 2, and then comma the answer that you got, which was 14. Okay, so again, this is an acceptable answer, but get used to writing them like this. All right, we're going to do one last one. Just for fun, right? So again, here we have another piecewise function. It consists of 2 different pieces, but now they're asking me to evaluate f of 0. Here's my question to you. Which one should I use? What do you think? So is 0 less than 0? Or is 0 greater than or equal to 0? What do you think? Okay, this is a tricky one, right? 0 is not less than 0, so we're not going to use the top one. 0 is greater than or equal to 0. So it's not greater than, but it is equal to 0, right? So since it has this equal one, it fits in this one. So that means I'm going to be using this equation. Okay, so again, don't let that confuse you, but 0 is equal to 0. So that's why it falls under the one that has the equal sign. So I'm going to replace the 0 in the x. So instead of 3x, I'm going to put 3 times 0 minus 2. 3 times 0 is simply 0. Minus 2 gives me negative 2. Again, I didn't put it in here, but go ahead and write it down on your notes, please. What number did I use for x? I inputted a 0. And what answer did I get? Negative 2. So this would be the correct answer for evaluating this piecewise function.